Okay, because only 43 are there in the class, half the strength. Mass recruitment is starting.
Yes.
Started. Any other company? It's coming, by the way, this week.
Not sure, ma'am.
Okay.
Cognizant interview is coming, ma'am.
Test is done.
Interview, ma'am.
That's what I'm
Cognizant.
interview like usually it will start with the test then interview, right?
Yes, ma'am. Test completed, ma'am. Now today and
Completed.
tomorrow interviews. Yeah.
Okay, then they both are mass recruiters like TCS and CTS. Then many students will be busy with that, right? Yesterday ITCT test over.
No, ma'am, it got postponed to tomorrow because there was exam yesterday, some placement exam.
Oh, okay. Okay, fine. Um, the assignment you could complete, right? All of you tomorrow. Will you be able to do it?
Yes, ma'am.
Anyway, I've shared the link, the MS Forms link in the post. Please upload there. Okay. So now I'll go ahead with the class. Yesterday we discussed with D algorithm. Next, before we enter into the next type of algorithm, Podem, little bit we'll discuss about sorry, fault cone, forward implication, backward implication. Fault cone means any bigger circuit, generally the huge circuit. What they will do is they will divide it, they will cut it. And for each partitioned set, they will perform ATPG algorithm and they will try to get the test vector. So the portion of a circuit whose signals are reachable by a forward trace of a circuit topology starting at the fault site. Like if a bigger circuit is there, if you cut that circuit, a part of that circuit, we call it as a fault cone. Forward implication means any gate, inputs are known. So you are in the process of identifying what will be the output of that gate. Then the process, we call it as a forward implication. Backward implication means you know the output, you know one of the input. Based upon this, you are going to identify the other input. In this process, we call it as a backward implication. Next, moving on to D frontier and J frontier. D frontier means you know the inputs, you are in the process of getting the output. Then that particular gate is known as D frontier gate. Understand the difference between forward implication. Forward implication is the process in which you know the input and you are trying to get the output is known as forward implication. So in the forward implication, a particular gate which is involved in the forward implication, that gate we call it as a D frontier gate. In the backward implication process, there will be a gate involved. That gate is known as a J frontier gate. Is it clear, students? Students, please tell me, is it clear? D frontier means the gate in which you will be following a forward implication procedure. J frontier is the gate on which you will be following the backward implication procedure. Clear?
Yes, ma'am.
Demerits of D algorithm. As we have seen in the path sensitization, there also I told we are sensitizing paths one after the other and it is a tedious job. Same thing still exists here. Even here, if a multiple paths are available for a particular circuit, we will sensitize one at a time. And backtracking with respect to going and checking the propagation D cube, then going and checking the singular cover, that is known as tracing. Here it is too many and it is time consuming. You know, if you look at the table itself, for a smaller circuit, such a huge table we are drawing. If the circuit is bigger, then the table size also will go on increasing, and multiple times the same singular cover we are entering, propagation we are entering, and it is time consuming. So because of this problem, we move on to the next type of algorithm, Podem. Path-oriented, full form for the Podem is path-oriented decision making. The full form for this Podem is path-oriented decision making. Now let us look into this algorithm. So this is a circuit given to you. There is a fault specified at the primary input A. The fault is stuck at 0 fault. Now, first step, what you have to do is you have to create a table like this. So in the table, for all the variables given in the circuit, you have to enter it, each variable in each column. Now A, B, C, D, E, F, G, H, K, L. So A, B, C, D, E, F, G, H, K, L. So all the variables I entered here. But remember, for all the gates present in the circuit, a variable should be assigned. By mistake, if in the circuit variable is missing, you yourself assign it and add it in the table. Okay, and these are the columns is required in the table. Apart from that, two more columns are also required. One column for the D frontier and one column for the J frontier. So this is the table first you have to draw. Then in this table, you need to fill the values. So now first let me tell you, even here we are going to follow those three procedures: activation, propagation, and line justification. So if it is activation, fault is present at A, fault is stuck at 0. How I can activate this fault? Can anyone answer how I can activate this fault?
Initializing with 1.
Which with 1?
A, ma'am.
Initializing A with 1, I can activate this fault. If I initialize A with 1 and fault is 0, so this fault is represented as D or D dash?
D.
So here, let me write D. Next, activation is done. Now I am trying to propagate it. So from A, I need to take it to E. So the next row, D, I need to take it to E because this is an AND gate. So definitely I will get D only. So to propagate it, B should be, what should be the B value? What should be the B value? To propagate the fall from A to E.
1, ma'am.
1. Next step, D, 1, fill all these things. Now from E, I need to take it to F. So if from E to F, if I want to take, what should be C? Vamsi Krishna. Two Vamsi Krishna should be there. Only one is there. Okay, BV and Vamsi Krishna.
Yes,
Tell me. From E, I have D. From E, I need to take it to F. What should be my C? This is an OR gate.
C should be 0.
C should be 0. Okay. So let me copy this once again here. Now our fault is at F. From F, again I have two parts. Let me take the top one. So from F, let me take it to G. D dash. So G, I will get D dash. So from G, I need to take it to K. Then what should be my D? Mauli. Chandramauli. Chandramauli, are you there? Sai Praveen, are you there? Sai Praveen, just connected. Bharat.
Yes, ma'am.
Bharat, tell me, what should be the A value? So D value. This is our gate. Actually, at G, I have D dash. That I'm taking it to K. If I want to take, what should be my D value?
D dash.
D dash. Are you listening? This very clearly tells that past 2 or 3 days you are not listening to the class. Am I right? Then what? If I want to propagate the fault through a OR gate, what should be the other input? I asked you guys to remember, na? Gautam Subhas. Listen to the class, Bharat.
0, ma'am.
So D should be 0. Okay, now from Gautam Subhas only answer. From K I have D dash. This I need to take it to L. This is a NAND gate. So what will be L? D or D dash? Input is D dash. NAND gate means D or D dash I will get. Gautam Subhas. Don't know? Don't know means tell. Gautam.
Yes, ma'am. I'm confused in the.
If it is an AND gate, whatever you give, if you give D, you will get D. If you give D bar, you will get D bar. But if it is an AND gate, if you give D, you will get D dash. If you give D dash, you will get D. Remember this. This logic is applicable for OR and NOR also. Suppose in this R, if G is D, K will be D. If G is D dash, K will be D dash. If this R is replaced by a NOR gate, if G is D, K will be Gautam Subhas.
Ma'am.
Hmm.
D bar, ma'am.
D bar. If G is D bar, if this is an OR gate,
D, ma'am.
D.
D.
Understand? Okay. And remember, for
Yes.
NOR and OR, other inputs should be 0 always. This is for even Bharat. For NAND and AND, other inputs should be 1. Clear?
Okay, ma'am.
This concept, this logic you will be using in path sensitization, D algorithm, Podem. So please remember all these 3 algorithm uses this concept. And this is same always, default. There won't be any change. So please remember. So now what should be the H value? Sivanath Nikhil, what should be the H value if I want to take the fault
1,
from
ma'am.
H should be 1. So whether we have propagated
Yes.
the fault, now we have completed the job of propagation. Now we need to check for what is the next step, Sivanath Nikhil.
Line justification, ma'am. From
Line
back to front, we have to.
Now H is 1. As of now, we have kept H as 1. F is already fixed, it is D. And A is already fixed to D. Can I get H as 1? See, look here. H is 1.
No, ma'am.
No, just think F is D, A is D, D XR D, what you will get?
Okay, ma'am. Same. We will get 0 now, ma'am.
0. So line
Yes, ma'am.
justification is possible here?
No, ma'am.
No, line justification is failed. So whatever path,
Yes.
actually speaking, here for the fault A, there are many paths are available. I took the top one. And here also I took the top one. If I would have taken the bottom one or the bottom path, maybe I would have got the result. So here I failed to get the answer. So now immediately you have to start working on with the next path. Now I forgot to tell you D frontier and J frontier. Remember, here first I activated the fault. During propagation from A fault, I took it to E first. So 1 will come in D frontier. The gate number 1 will come in D frontier because I know the input. 1 minute. We were knowing A and we are planning to take that to E and we were identifying what is B. So input we are checking. So that is D or J frontier. Input we are calculating. B we calculated. So that is J or D frontier.
D frontier.
D frontier. D frontier, I told it is similar to forward implication. Forward implication means you know the input, you are calculating the output. But what we did here, I know A, I know what should be my E because I am in the aim of propagation. So I know what I should get at E. I know what is A. I was in the verge of calculating B. So input I was calculating. So input I was calculating means it is backward implication. Backward implication goes with J frontier or D frontier?
J frontier.
J frontier. So here I need to write 1. Here nothing. The first one, nothing. And in the next step from E, I know E, I know F, I was calculating C. So this 2 also will come in J frontier. Next from F, I moved on to G. And 3, in the same step, I filled everything. Same step, I filled everything. I propagated from F to G and G to K and K to L. Maximum, it's up to you people. But don't try to complete all the thing in one. Split it, but don't split it completely. It's up to you. So here I moved from F to G. So here I didn't check for any input or output. I know F, so I got, okay. I know F, I calculated what is G. So this would come in D or J. I know F, I calculated what is G. That way we can consider this NOT gate. So this would come in D. And I know G, I know K, and I calculated D in the same step. So this 5 will come here. And K to L I moved, 6 also will come here. Now when I did the line justification in the next step, 4, I know the output. I was calculating the input. So this also will come in J frontier. So based upon what step you are doing, what you are doing in that particular row, accordingly you need to fill the gate values here based upon what you are calculating. And students, this values, whatever we write in J frontier and D frontier, maybe there may be slight deviation from your answer and your friend's answer or maybe my answer. So that is acceptable. Suppose if I'm having an answer key like 1, 2, 5, 6 should get, your way of thinking might be different and you might have done the steps. The last step you would have written 3 different columns. Accordingly, this J frontier values will change. Maybe first 2 steps you would have done in 1 row. So this 1 and 2 will come in 1 row only. So it varies. So J frontier and D frontier, mainly exam point of view, I'm telling, when I check this answer, I will try to understand whether you guys have understood the concept or not. Accordingly, have you filled or not? Your answer and your friend's answer will definitely vary. The way you fill this table, way you enter the values in rows. Is it clear, students? Now, shall we take the lowest one and try? The lowest row and try. Let us try that. Here I had D. So this I want to propagate here. So from A, I want to take it to H, D. What is my F? What should be my F? XOR gate. If it is 1, will it work out? Or it should be 0, it will work out. A is D, H is D. What should be F?
0.
0. F should be 0. So this gate number 4 will come under D or J. I know A, I know H, I calculated F. So input I calculated. So this will come under J frontier 4. Next step, again, write that whatever you have filled in the previous row. Okay. Next, from H, I'm taking it to L. NAND gate. So D dash. A should be 1. So the gate number 6 now, which I worked upon in this row, will also come under J frontier. Next, fill the same thing once again. D, D, D dash, 1, 0. Propagation is done. Now I need to go for the line justification. So here in line justification, K I took 1. We have to move from the backward. So K is 1. If I should get K as 1, G can be 1 or D can be 1 or both can be 1. Already we have set F as 0. If F is 0, G will be definitely 1. So because G is 1, I will automatically get K as 1. So this D, what should be by D? Can
X.
anyone tell? X. D can be X. So now I was knowing K. I calculated D and I calculated G. Again, inputs I calculated. So this 5 will come under J frontier. J frontier, I'll check it once again. J frontier comprises gates whose output value is known. So we are right. Okay. Next. So I have done the line justification for 3 and 5. The next step. Now, F is now 0. This part is done. This part is done, student. This part is done. Now F is 0. Can I get F as 0? When both the inputs are 0 only, I can get F as 0. So here E as 0 and C as 0 because this is an OR gate. So output I know, I calculated the input. So I will write here 2. Next, E is 0. Can I get E as 0? A is already fixed D. So if, let me copy this. Now we are here. E is 0. Can I get E as 0? If I set B as 0, I can get E as 0 because A is already fixed to D. I cannot change it. So B as 0. So now we are able to do the line justification also. We propagated the fault through this path and we did the line justification here. First we did for K. When I did for K, I did for G also. Then I did for F. Then I did for E. So line justification is done. Now finally, what is my test vector A, B, C, D? A, this is a fault D, but how did I activated the fault? By keeping A as 1, B is 0, C is 0, D is X. 0, 0 is my test vector. Our last step also here it will be 1. Is it clear? Now, I want you to try. We tried this path. A, E, F, G, K, L, which failed. Then we took A, H, L, which worked out. There is one more path, A, E, F, H, L. Try that path and tell the status. A, E, F, H, L. A, E, L, H, L. Solve this now. A, E, F, H, L. I will also do here. Is it possible to propagate here? F is D, A is D. Propagation is possible, students?
No, ma'am.
A is D, F is D. So H will be 0, right?
0, ma'am.
So we cannot propagate. It's not possible. Others, please tell me. Am I right?
Yes, ma'am, it's not possible.
It's not possible. We cannot propagate. So this is ruled out. Any doubts, students? So for this question, for the Podem algorithm, try to fill these values properly. This D frontier and J frontier accordingly for each row, whatever answer you are getting, that you try to fill here. My main exam point of view, I'm telling, main concentration will be given to this part. This part is same to what you do in the path sensitization. You fill there only everything, but here you are doing it in a table. And this is also same as what you do in the D algorithm third step. The path sensitization, D algorithm third step, and this part is also same. But why they are named as Podem, path sensitization, D algorithm is actually D algorithm goes with singular cover and propagation D cube. If we want, we can do it directly also. And here they say Podem goes with the D frontier and J frontier with the help of checking whether I'm doing forward implication or backward implication, which gate I'm analyzing now. So by filling noting down the D frontier and J frontier gate, they say if you proceed, it will be easier. The person who have identified this Podem algorithm. But what do you people feel? Without J and D, entering the remaining stuff is easier for you, or with the J and D is easier? Tell me. No answer. J frontier, D frontier, to my understanding, like little bit, it will confuse you. Whether I have to enter this in D or whether I have to enter this in J, when I have to enter. So be clear with the J frontier and D frontier concept, and if, but then and then if you enter, it will be easier. Okay, and here maybe generally students will ask, ma'am, when I should move from one row to another row. Maybe for each step, if you have a habit of moving, that is also okay. Activation from this to this, one row, from here to here, one row, from here to here, one row, from here to here, one row. Next, line justification, this to this one, this to this one. So many entries. Here, suppose from K to F as one row also you can make. You can simplify it. 2 steps you can merge in one row. That is also allowed. You can do it. Is it clear? Podem algorithm. But the problem is, if multiple paths are there, first try with the first path. If you are getting the answer, you are lucky. If not, you have to try immediately with another path. The table has to extend. Is it clear? Students, is it
If we are doing another path, can we just completely come to a new table because it's confusing?
It's up to you if you want to go with the new table, if time permits. If not, actually this line, row line, column line and all not required. You know, you are college students, like align it properly and fill it.
Okay, ma'am.
It's up to you how you're managing the time. Any doubts, students? Or you're listening? Gautam Reddy, Sai Mahit, are you listening? Nikita?
Yes, ma'am.
Meghna?
Yes, ma'am.
Meghna Reddy, are you listening? Venkata Meghna Reddy?
Yes, ma'am. Yes, ma'am.
Sai Sriram, Kartik Sai. Sarfaras, many times I've called, even till now I didn't get any response from you. Varun, Priyanka, today I could not hear anything from you, Priyanka. Sumalata also I could not. Sumalata is not there today. People who respond regularly. Raymond, Banu Prashant,
Ma'am, yes, ma'am.
Nagasai Kumar, are you listening? Sometimes you will open up.
Ma'am,
Sometimes
Varun
most of
ma'am,
the
yes ma'am.
Varun, you are there. Nagasai Kumar, Sahana, Sonia, Sahana. Sonia is going to answer now. Sonia. Sonia, you are unmuted, but I could not hear your voice. Sahana. Virendra Sai. Sahana, are you listening?
Yes, ma'am.
Did you understand how to solve this Podem? Any
Yes.
doubt?
No, ma'am.
See, students, only thing I wanted to tell you is be clear with these steps. Activation. Activation means if fault is 0, that particular signal line assign 1. If fault is 1, that particular signal line assign 0. Next is fault propagation. AND gate means, NAND gate means other inputs should be 1. OR gate means, NOR gate means other inputs should be 0. Similarly, for XOR, you have NOT gate, nothing. So this is the second step. Then line justification. So if line justification fails in that particular path, you have to move on to the next path to get the test vector. So this is what happens in path sensitization method. But the same procedure we are doing in D algorithm, same procedure we are doing in Podem. But in D algorithm, you should also extra know to fill the complete table, how to get the singular cover and propagation DQ for each and every gate. That concept is same, default. Already I've given you all the tables. That you should understand. And here, what is meant by J frontier and what is meant by D frontier, you should understand. And that particular gates, you have to fill it in the table for each and every row. So that's about the Podem. Problem. You to solve the problem. It's for a practice. I'm telling and nobody is doing. I can understand you are busy with the placements. But if you have time, or at least before the exam in semester, definitely these topics are there for the INSEM, 100% sure. So you can take a screenshot of this and solve this question or solve this circuit for D algorithm, stuck at 1 fault at J. And for Podem, stuck at 0 fault at G. Where is G? Yeah, here G. This is a circuit. Question is, this is not answer, this is a question. D algorithm, J stuck at 1, Podem stuck at 0 at G. Clear? Solve this. Have you taken the screenshot?
1 minute.
Yes.
Yes, ma'am.
Okay. Next two algorithm, fault table and ENF method. And before I move on to fault table and ENF method, my next class is Tuesday. Tuesday, any problem in having the quiz, students? Any placement or something is there? Anything is informed? Please tell me. No answer. That means nothing is there. Or you don't know till now anything.
Till now, nothing is scheduled, ma'am. They may schedule. Till now, no information.
No information. So, okay, I wanted to have not during the class hours, some other time. Can you people tell me what time we can have the test quiz? Quiz
Actually,
is for 11 marks. Students, remember, quiz is for 11 marks. So you will have MCQs, you will have descriptive, like giving the answer, everything will be mixed up there. Okay. I don't want to have it during the class hours because I need to complete the syllabus. So you tell me the time in the afternoon sometime.
Afternoon project presentations will be there, no, ma'am.
Tuesday, wa?
Yes, ma'am. November 2nd onwards, project presentation are starting.
Correct. So during the class hours only we will plan then. But if you have any problem like any placements or many may not be able to attend means you please inform me. Okay.
Okay.
Hmm.
Ma'am,
Okay,
so,
syllabus is
ma'am, for quiz 2, no need to scan and all, no, ma'am.
what ICTC they told? They asked you to scan?
No, they told no accurate information, ma'am.
That same confusion even I'm there. First initially they told like even if you are conducting the quiz MCQs, if they are giving an answer, selecting one answer, they need to give a justification in a sheet of paper and that paper have to be uploaded. So if even though you are giving MCQ answer as correct, I will come to know. But how you got that answer, if you show the justification only, I will give you mark. Suppose 2 mark MCQ. Answer is right. So I will not give just 2. In the paper, if you have written the calculations or reasons only, I will give 2. That is how they asked us to conduct the quiz. That this happened before midterm. This was the instruction given to us. Now I don't know how other faculties are going or something. Anyway, still time is there. No, I will decide on that. If you people need to write, I will inform prior to you. Okay, Gautam.
Okay, ma'am.
Okay, other students. I'll let you know. But now you remember syllabus is fault equivalence, fault dominance, checkpoint, checking whether a fault is a redundant fault or not, checking whether the faults are equivalent faults or not. So based on all these topics. Long back I announced for the second quiz, same topics only. But this quiz is for 11 marks. Remember, 11 marks. So MCQs, descriptive, everything will be mixed up there. Through AEMS only I'm planning to conduct. Whether you need to give some justification reasons in a sheet of paper and upload it, that I'll let you know. Or directly give your answers, that part I'll let you know. Okay, so now, only 5 minutes, okay, we'll start. Now look at, this is a fault table method. Listen here, I'm going to explain you now fault table method. This is the title, fault table method. This problem we will see later. First, I will explain you the smaller one. Are you able to see the diagram?
Yes, ma'am.
So there is 2 inputs A, B, 1 OR gate and 1 NAND gate. So here A line, for each and every signal line, I have given a number. Output is Z. So Z is equal to A plus B into B. The Boolean expression Z is equal to A plus B into B. That I can write it as AB plus B. So for all the inputs and the final output, the variable is assigned. And for all the signal line, even the input, except the output, for all the signal line, except the output, for all the remaining signal lines, I have assigned a number. So fault table method, number will be there for all the signal lines, even for a stem a number, fan out branch and another number. So this is 1, 2, 3, 4, 5. I didn't give a number for the output. Okay. So if I'm giving any question for the fault table, I will give the numbers. I will give already the numbers in the circuit. In the circuit, numbers will be there. Okay. So this is the circuit given to you. Using fault table method, you need to find the test vector. Okay. So this is this is something different compared to the algorithm, ATPG algorithms we have come across till now. In all the ATPG algorithms we have come across till now, we introduced the fault and we were getting the test vector. Which test vector will detect the fault? But in this fault table and ENF, this is not coming in the category of the algorithms which you have come across till now. These two algorithms are a little bit different. Okay, so when I use this algorithm, we will not take a circuit with a fault. We will take the circuit as such, and in that circuit, main constraint is if I want to use a fault table method, all the signal lines should be assigned with a number. Okay, so now first I need a table. This table is known as fault table. See, remember student, this table is known as fault table. So what are the entries should be there in the fault table? AB is the primary input of this complete circuit. So AB. Z is the output of this complete circuit, Z. So primary input and primary output alone you have to enter here. Next, numbers 1 to 5 I have. So, okay. So now the first number 1 that I represented as F1. F1 in the sense fault at 1. F1 in the sense fault at signal line 1, but the fault is 0. So if I write F1/0 means F1 represents the signal line 1, which is having the fault 0. The next one, F1 with the fault 1. Each signal line 1 means I need to check it out. Well, I need to consider it for a fault, stuck at 0 fault and stuck at 1 fault. Next one is F2. F2 for 0 and F2 for 1. Next is F3. F3 for 0 and F3 for 1. Next 4. So F4 for 0 and F4 for 1. F5. F5 for 0 and F5 for 1. All I wrote F1 0 1, F2 0 1, F3 0 1, F4 0 1 and F5 0 1. So this is not required. So this is not required. So this is how the things should be. Now, how we will make the entries? Z is the normal output, actual truth table. What is actual truth table? What I should write here? Expression is AB plus B. A is 0, B is 0. So Z will be 0. What will be for 0, 1? 1 na? Truth table. B is 1. So 1 I will get. This is OR operation. A is 1, B is 0. So 0. Then this will be 1. So first I wrote the truth table. Next now you listen here. F10. F10. That means in the signal line 1, if there is a stuck at 0, for the given input 0, 0, what will be my output? Again, F1 of 0 means the signal line 1, there is a stuck at 0 fault. In that situation, if I give 0, 0, A, B as 0, 0, what will be my output? What will be your output? A is 0. Fault is also 0 in the signal line 1. Will there be any effect at the output?
No, ma'am.
No. So what will be the answer here? 0. Next combination also 0, 1. A is 0. Fault is 0. So output will be same as the original one. There won't be any difference. Next, A is 1. If you take for this combination, A is 1. Fault is 0. So there will be definitely in effect. So A is 1, fault is 0. So that means this line is always 0. So 5 depends upon 3. 3 depends upon 2. 2 is nothing but our B. B is 0. B is 0. So 2 is 0. 3 is 0. So 5 will be already 1 is. So 0, 0, 5 will be 0. But this input is 0, Z will be 0. So here 0. Next, 1 is stuck at 0 only. Still we are in the same column. 1 is stuck at 0. 5 depends upon B. B is 1. So 5 is 1. Input to the AND gate is 1. Z depends upon 4 now. 4 is depending upon B. B is 1. So 1, 1, Z is 1. Any doubt? Base, include the fault here. For each input combination AB 0, 0, 0, 1, 1, 0, 1, 1, what is the output you are getting when the fault is present? That you need to fill here. Now, fault 1 is having stuck at 1 fault. So here I have a stuck at 1 fault. So when A value is 1 and fault is also 1, there won't be any difference. So this 0, 1, this 0, 1, I can around say fill here 0, 1. These two values I need to think and do. So like this, F2 of 0 means I need to consider only fault at the stem. Stuck at 0 fault, stuck at 1. Next, F3 means I need to consider fault only in the first fan out, 0 and 1, and you have to identify the output. Like that, you need to fill. So when you come for the next class, I want you to fill the complete table and come. Is it fine? Are you able to understand? Please tell me. I'm not able to see your face and I'm not able to predict.
Yes, ma'am, understood.
So please try to solve this. On Tuesday, I can extend the class, right? This Tuesday also extended the class, no? So coming November 3rd, I planned for the quiz. So definitely I will extend the class, students. First I will take the class, first I will complete the fault table method, then only I will conduct the quiz. Okay? Thank you for today.
Thank you, ma'am.
Please submit the assignment by tomorrow 6 o'clock. If you have any problem in submitting, please get back to me. Tomorrow evening 6 o'clock, the link I've shared it already in the 15EC369 post. It is there. Thank you.